please join. So, a little bit about myself. I'm Stephan. I'm a developer living in Paris. I have a long-standing interest in functional programming and data analytics. I have some experience with R. So I have used R to perform data analysis and to have data visualization. And the last couple of months, I told myself to look into Scala tools to see what is there available. This is the result. I made a test drive with several Scala tools, and let's see what we have now. So very quickly, data visualization of what is needed for. So it's used in data analytics when you want to make exploration of a data set. So being able to generate a lot of plots for your data is could improve your knowledge of your data set and pinpoint you in the right direction of the analysis that you need to perform. And then visualization is also important when making publishing results, and it's especially important that the analysis is reproducible. And for that, yes. Yes, sorry, I'll try. Yeah. So I was saying that in results publication, you may want to have to be able to showcase your code, your analysis, and your visualizations. You can use it also in your simulations. You can make dashboards. That's especially for your boss dashboards. And well, the last point is well, everybody likes eye candy. Okay, so this is more of a personal choice because what I have found out is that there are many Scala tools. So I have settled only for 3 of them. So these tools are Bokeh. I hope I pronounce it correctly. It's a Japanese term apparently. So I think it's called Bokeh. The next tool is Sparkle, which is used for big data or for streaming data. And the last one is the Scala Notebook. Now there are other tools that can be used, other Scala tools that can be used for visualization, but not everyone made the cut. So okay, let's get started with Bokeh. Now Bokeh is actually part Python, part JavaScript project. It uses Python on let's say a server, and it displays the visualization with a JavaScript library. So it's 2 parts. It is a relatively recent project, so it's advancing at a rapid clip. You can already make a lot of plots with Bokeh. And the nice thing about it is that it recently there have been some Scala bindings that have been published. You have the GitHub repo there. Actually, you can use the Scala you can totally write your visualization in Scala and then execute it and have it displayed in a browser. Bokeh uses what is called the grammar of graphics, and well, I believe that is useful for defining relationships between the elements of your visualization. Okay. I guess the best thing is to showcase what it can do. Okay, so here are some examples that come with the Scala bindings. So to just see what kind of plots we can make with Bokeh. This is all displayed in the web browser by the Bokeh JavaScript library. So here we have a chart composed of four plots. Another example, this one, we can have maps, and we can have, this one is for the USA unemployment data. We can have what is called a data grid. This is interesting because we have different kind of data types here. We have numerical values, and we have also categorical or factor values. So we can, for example, we can edit. We can have, for example, we can change the data here. For example, okay, and we can. Okay, next example would be a simple plot. This is a sine, apparently. We can, for example, we can save it. We can save the plot actually as a PNG. And as you can see, since I captured I think we can see another feature. Actually, we can move the plot around, and as you can see, the scales follow actually the plot. Also, both on the x-axis and the y-axis. For example, we can have moving plots together. We can moving plots together. What can we have as an interaction? Another example would be hovering over a data point. Another example, this is the iris dataset, which is used usually in machine learning 101, and colors here represent different classifications. We can have, for example, on the same dataset, this kind of chart where we can see the relation between different attributes of the dataset, all on a single chart. And apparently maps are not working. Okay, so these are some examples of plots we can do with Bokeh. So let's see now. Oops. Yeah. So let's see how we can write a small app in Bokeh and have a data visualization. So we create a simple object extending the app, and we have to make just 4 steps. Well, the first one is, we won't talk about that one. The second and the fourth steps are very easy. It's the third step where we are building the plot is a little bit more involved. So let's see, this is how we load the data source. So these are X and Y, for example, are arrays or vectors. And we define the data range for the x-axis and then for the y-axis. We create a plot with the defined ranges. We can add some tools, like moving around or zooming in or out. We create the axis and we add them to the plot. We can add them wherever we want to. We need to define the way we will display the data points. Here I have chosen a circle. And then we add all these renderers for the axis and for the data point to the plot. The last step would be to save it in a HTML file, and well, we can also view it right away. So let's see how this works. So, for example, here's we will build a scatter plot, just generating some random numbers. So here we define our data range. Well, it's the same code that we have seen in the slide. So let's see how we run this. Don't see it very well, sorry for that. So I just ran SBT. So I have the choice of plot that I want to showcase. So it has been displayed here directly in Chrome, Google Chrome. So as you can see, we have random points, and we can use the pen tool. Okay, so this was a very simple example. Let's take a look at something more involved. We would like, for example, to add a title or add labels to our axis. So here I am loading a dataset, which is the consumption of milk, tea, and coffee for a number of years in the USA. What we can see here is that for the y-axis, we can select as range the sum of these three data sets for milk, tea, and coffee, and it will take actually the minimum and the maximum of these to generate the y range. And then we add here the title and everything. The rest is everything the same. We add a legend, and we need to add this legend to the plot. So going back in SBT, run it. So here it is. And this is a time series. And this example I'll be using also in the other tools. So you'll have an idea, you'll be able to compare what each tool is able to do. Okay, and let's see one more last example for Pocket. This is well, I should be showing you the dataset before. Okay, so what we will make as a visualization is about recognizing bacteria. So we have this column here. The first column is the bacteria name, which we see there are some scary names there. Then we have 3 columns with what I presume is the treatment. And the last one is not a numeric value, it's a factor one. It's a way we can recognize, it's a test that we can use to recognize a bacteria. And these tests have a gram-negative or gram-positive result. Okay, so let's see how we can visualize this in a fancy way. So I'm back in SDT, running. Okay, so we have it here. So this is not a generic plot that you can have in the API of Bokeh. You actually need to build this. Well, you have to. So I needed to calculate angles and gradients and so on to have all these bacteria and the treatments and all displayed in a circle. So yeah, with these examples you can see what we can do with the Bokeh library. Okay. So let me ask you, how do you want to ask questions at the end, or do you want to ask questions after every tool I showcase? What do you prefer? Do you want to ask any questions right now?
Yes.
Does this rely on external dependencies like SVG libraries or something? Is the Loki full JavaScript library that display this in the web page?
So actually, like I said before, Bokeh is composed of a server, which is written in Python, and a client. So the dependency that you have is this JavaScript library. This is displayed with a JavaScript library. And the bindings that we have in Scala are actually working with the server. So we write the Scala code, we generate a web page, and that web page is using the Bokeh JavaScript library to display this. No other dependency.
Sorry,
Yep.
I'm still not quite clear I understand that. So I write my code in Scala.
Yes.
When I run that thing, it's talking to some Python server somewhere
Yes, I guess.
to do things.
Yeah.
But then the HTML file I have, I can just embed in my JavaScript application.
It generates a web page. I haven't tried it. True. It would be interesting. Yes. I don't know. If you want to stay after the presentation, we can see what we can do.
Well, I see that Python makes things more complicated. Isn't it possible just to write Scala backend and use it with this front-end library?
I don't know. I think, well, actually, it should be possible because in the end, all the displaying is done by the JavaScript library. So technically, I don't think that there is any obstacle in writing the backend in any language that you want.
And does this backend do a lot of work, or most of the work is done on a front-end part?
Well, the backend is just generating the elements that needed to be displayed, and the display is done on the JavaScript.
I mean, it's different computations like how to arrange those bacteria. Is it done on a front end, or it is done on the server, and then the server sends positions to SVGs or whatever is used there on the client?
I don't know. I don't know that. Okay. So I'm going to the next tool. Okay. So the next tool that I want to show you is called Sparkle. Not to be confused with Sparkle. So it is used. Actually, it's trying to fill a specific niche. It's not a generic visualization tool. It tries to cater to the big data and to the real-time data context. So Sparkle is capable of creating dashboards, and what it shows in these dashboards are data that is either incoming. You can have it incoming, for example, as Kafka. It also has recently added Spark as connector source. Or you can have all the data in CSV files, or have it stored in a Cassandra database. So how does this work? Similar as with Bokeh, you have a server part and a client part. The server part is in Scala, and the client is using the D3 JavaScript library. And Sparkle actually comes with another library called SG, which sits on top of D3. And this library is specialized in the sense that it is specialized for time series. Currently in Sparkle we can do only time series visualizations. So between the server and the client there is a protocol defined. And this protocol is allows the server and the client to be decoupled. In principle, we can write our own client for the Sparkle server. A neat thing that could be used are data transformations which are built in on the server side. For example, if the data is way too big to be transferred to the client, we can issue aggregating commands. So these aggregating commands will be like a mean or a maximum or a count on a specific billing of timelines. Okay, so let's see what Sparkle can do. Okay, this is a little bit more involved, so bear with me. Okay, so I have started the Sparkle server. Here I am going to the web client. The client and the server are communicating on a specific port, which in our case is 1, 2, 3, 4. Let's see. Okay, this didn't work very well. Well, this is demo effect, I guess. I guess, I'm sorry, this is not working. I should have tested right away. Okay, I guess I'll abandon this one. Sorry about this. Okay, what I would have liked to show you is how to write a simple chart for Sparkle. So this is what we need is in an HTML template where we specify our JavaScript, because in the client we will write a small part of a JavaScript code. We just define require JS as dependency, and then our small JavaScript snippet is like this, where we can use D3 and the SG library. So we build a chart, and we add that chart to the dashboard. We can have several charts in a dashboard. Here I have only one. And this is how we create a chart. We define a group and we take the names from a CSV file. We give the name of the CSV file and the name of the columns, and Sparkle will take this data from the CSV file. Should I try again the demo? No. Okay. Okay then. Sorry about this. Okay. We go to the next one. So the next tool is Scala Notebook. So it has been built by Bridgewater, which is a hedge fund, and they have released it on GitHub. The idea of notebook comes from other projects like Python Notebook and Mathematica, and the idea is to have a document where we can write code snippets, execute those snippets, and have the results all embedded in that document. So the end result is a document which is interactive. For the Scala Notebook, it's pretty much the same principle as for the other tools. We have a server, which in our case is SBT, and the client, the web browser. and we execute Scala. Well, we write Scala code in a HTML document, and we have them execute that code remotely in SBT and have the result come back to and displayed in the web browser. Now, Scala Notebook has a history of forks because it initially, well, it works very well for generic Scala code, but for the visualization part, things are a little bit lacking. So some people have tried to include T3 visualization or bokeh visualization in the Scala Notebook, and here are some examples of projects that try to do this. So okay, let's go to a demo. Hopefully this one will work. Okay, so I have started SBT, and here we have, okay, let me just go back a little bit to the presentation. So what I will show you is the Scala Notebook, the fork created by Nathan Hamlin. It's the first one in the slide. Okay. So if you haven't seen the Scala Notebook before, it's not only for visualization, it's for any kind of Scala code. So let's go to the welcome page. So here it is how it looks like. You have a document, and you have a number of cells in it, and in a cell you can write Scala code, and then you can have it executed, and the results will display. So, for example, let's take the first cell here. Should I make it bigger? Better this way. So let's take a list and try to reverse it. We'll execute it like this, and we have the result right away. So I can edit the cell. For example, I add another element to the list. I execute it like this. It's not only Scala code that we can execute in a notebook. We can also generate HTML or SVG. For example, this is an HTML table. Okay, so these are the basic stuff. Let's take a look at some SVG example, because we can have SVG and canvas directly in the notebook. Now, as you can see, SVG is quite verbose and low level, so I guess it's not everybody's cup of tea. So these are things that we can do with SVG, but as I said, they are really low level. So probably something else is more interesting to have, like a JavaScript library that generates visualizations. Hence the idea of integrating Bokeh or a D3 with the Scala Notebook. So this Scala Notebook integrates, let's say, partially with D3. It can generate a number of plots with D3. So let's take a look of an example. So here's the same thing that I have shown you before with Bokeh. It's the same data set of milk, tea, and coffee consumption in USA for a period from 910 to almost today. So I have loaded the data set and putting them in a map. And here I am displaying a plot. So this part is for consumption of tea. And we can reuse the same, by injecting different data into the plot, we can have the plot change immediately. So let's put the milk data into the plot. Like this. And let's take a look at the coffee data. Like this. Okay. Now this is all very neat, but the D3 integration is more like a proof of concept. It's not like you can do any kind of D3 plot with the Scala Notebook, but it's more like it's a showcase of what can be done with it, what the potential of the tool can be. And Nathan Hamlin came up with a really cool example. So let's see if we can. No. I think I do not have actually. Yes, I do not have connection. This was. Well, if I don't have internet connection, I cannot really show it to you. Do you see? It's here. Any script?
ScalaIO.
Like this? Okay, let's try again. Well, I go from the start. Yeah, that's more like it. We are not in Lyon nor in Grenoble. But anyway, that's the provider. Okay. So what Nathan Hamlin has done in this demo is he connected to the Meetup server, and he's receiving activity of the Meetup server in real time. So he's plotting that activity on a globe. So here is the globe. This is a D3 widget. It's not quite Paris, but it should have been. So we can move, the center of the globe. So the globe is spinning around. This is New York. So this is just for showing the cities and where the activity originates. and we can launch. So yeah, you can see the activity on the meetup site. It's a cool visualization. Okay, do you have any question about Scala Notebook? Yeah?
Does any of the libraries you presented can handle millions of points? Have you done or have you run some benchmarks about it?
I don't know about benchmarks. Sparkle, the second tool, it's supposed to work with a lot of data, with big data, but I do not have any benchmarks. Sparkle, what it has, I have mentioned it on a slide. It has a transformation where you can actually reduce the number of data on the server side before transferring to the client. Yes?
Did you try some interaction between the maps you generate and the data you have on the server side?
Do you have something specific in mind?
I mean, if you want to filter through a subset of data, for example, on the charts or on a set of time and space.
As it was previously, the previous question was about data size, and well, Sparkle can do that. Sparkle, you can instruct Sparkle to reduce, to perform a number of transformations on your data in order to reduce. So you can bin your data set, your time series. You can bin it on, let's say, 1 hour or 30 minutes, and on that part you can aggregate. You can perform an aggregation on the server side, and then the result have it streamed to the client. Okay, so that was the demo. So I guess I have went really quick, well, especially the Sparkle demo that went very well. Do you want me to retry the Sparkle demo? Maybe it was the fact that I didn't have internet connection. Yes?
Sure, yeah.
No, I guess I'm unlucky today. It doesn't work. Okay, so just a quick conclusion. I have the example on a GitHub repo there, and about these three tools, they are using JavaScript libraries, and the maturity of these tools varies. Like Bokeh, you can use it right away. It's a stable tool, while Sparkle is a still evolving one. But it has a nice activity on GitHub, so I'm quite sure that it will become a very good tool. And there is also a Scala Notebook, which you can already use, but the story of visualization on the Scala Notebook is a little bit mixed. So we'll take a look at, let's see what comes out of that project. So I guess that was it for me. Do you have any question?
So, I've got a JavaScript single-page application, and I want to put charts on it that preferably I can calculate server samples rather than do a lot of programming in JavaScript to do it. What currently would you say is the best, most likely option to get that working with minimum plus volume?
It's clearly Bokeh. Bokeh is the one that you want to use. Sparkle should be working too, but Sparkle is only for time series. So Sparkle is geared toward big data and real-time data. So it can do only time series. But if you want to pick one, a library, it's Bokeh. Yeah.
Well, it's not clear for me what is the profit of using stuff like Scala Notebook that does mostly of the things on a server, rather than just using some ScalaJS things like ScalaJS Fiddle that where you simply can write code that compiles to JavaScript.
Yeah, that's legitimate. Yeah, if you want ScalaJS, yes, why not? I don't know what's the level of ScalaJS. I'm not sure you can do you can do charts with it. I don't know. I haven't looked at it in a while. The interest of Scala Notebook or another project, another Scala project, is to have interactive documents. So, for example, when you perform a data analysis, you want to have all your code there. You want your analysis to be reproducible by a third party. So you write your document, and you give it to a third party, and they can execute the code and remake all the charts, and they can ascertain whether the results of your analysis are correct. That's the main interest of having it.
Actually, what is ScalaJS Fiddle doing? So you can give a link to the code, and it executes and compiles that code to JavaScript.
Okay. Any more questions? Well, I guess that was it. Thank you for your attention.
Whatever you want. You can also use libraries like D3.js because there are ScalaJS facets for this library, just like interfaces. So what is good about this is that you don't have to deal with writing JavaScript code for your visualizations. You can just write plain Scala and use it also for visualizations. In case of ScalaJS Fiddle is just to share ScalaJS snippets of code, but it's not hard to use to modify its code to use it for things like data visualizations. And there are several people who are working on data visualization libraries for ScalaJS. So you will be Scala all the way down in such case.
Okay, do you know the name of those libraries?
Well, I'm a part of ScalaJS community, but I don't remember all those libraries by heart. Actually, there is ScalaJS website, and they give some libraries that are already available, but it's a little bit messy. And I think that SVG library, we'll see if it is mentioned here. I don't see, I remember one guy did it, but what I know is that there is a facet for D3.js, so you can deal with D3.js and Scala. Then I'm writing 3D graph visualizations based on 3J, D3, so there is the 3 facet, and there is also 3D JavaScript libraries that does 3JS. So I wrote facet for 3JS, and now I'm writing 3-dimensional graphs with the Spring layout, and one guy is writing SVG library for rendering SVG things. I don't remember if he's doing it on his own or he's making a facet with some extra stuff.
So what's facet?
Facet, I mean, in ScalaJS we call, well, if we want to call native JavaScript library from ScalaJS, we can do it in 2 ways. The first way is just by using dynamic classes, but it's not a type-safe way. The other way is to define, for instance, I will show you D3 ScalaJS. I think it will not be hard. Oh, here is an example of D3 ScalaJS. So what is the facet? So here it is. So in fact, in this case, what we see here is that so we inherit from a class called JS object. It means that whenever it finds not implemented, it tries to get it from external JavaScript. Okay. And in your code, you deal with D3.js like with ordinary Scala code, so you get code completion, you get all the fancy ID stuff. And you can also extend this library by adding some new features on top of it. So there are a lot of libraries that already have ScalaJS.
Okay, so you're providing a wrapper, in effect, on the JavaScript that's there if it's implemented, otherwise it defaults to some sort of dynamic binding. And that gives you type safety on those things that you call.
Well, yeah, it just looks if there is D3 JavaScript included to the document, and if yes, it calls appropriate method of D3. Yes, that's the way how it works. But of course now there are some native ScalaJS libraries, and at the moment, people write rather complex graphical things. Unfortunately, I cannot show you right now my demo with 3-dimensional graphs, but for instance, I can show some games that are...
Oh, I see the games.
Yeah, like Roll, with 2-dimensional physics. Actually, what that guy did, he well, most of this game was his code, but he also used some physics library from JavaScript for this purpose.
Okay. Yes, I mean, and the other one, the first one you talked about, the vodka. I mean, it looks. So I get the impression that you've got two ways of doing it. One is to, as you code your Scala, run your Scala. That calls to Python. Python generates JS, which gives you an HTML, a JavaScript package for embedded in HTML, and that is what you then stick on your web page. Or you can do things that will push data to the Python server, or that's another way of using it, at least with Python. So I was thinking that while you were fiddling around with your demo, and make your JavaScript talk to that directly. So you're kind of using Python there somehow. I mean, I must admit, whilst Scala all the way down sounds a little bit more attractive to me, but on the other hand, whether they've done all those things. I mean, can you do those sort of linked graphs in D3?
Actually, yeah. I mean, the main difference actually is just that you use Scala all the way down and you can share code. I mean that in many libraries that cross-compile to Scala and ScalaJS, those libraries are used. For instance, I use PermWeld, that is a quite nice parser. I use several, I don't use Scala Z, but it is also already ported. Then, so you can, first you can use same libraries, then you can get your Ajax request results as futures. So you can do this match and then map and other operations on results of JSON Ajax requests, so you will deal with it in Scala. And of course, there are many, usually they call it Pickler libraries, so it's just serialization libraries. So you send case classes to the server and get something back, and it's usually it is serialized automatically. So you register the classes that will be serialized once just by calling register class name, and then you just send it, get future back, and deal with this class. So I think it's kind of it's very useful, at least for me, and that's why I try to do everything as my ScalaJS as possible.
Yeah, I have to make it all fit together with a fairly large single-page XJS application. So I've got to.
So what is the problem?
I don't know what the problem is. I don't know what the problem is. I haven't started. No, at the moment we have an XJS type thing that's just taking JSON requests for data and displaying stuff.
So you're using.
You're
using ScalaJS already?
No. So we're using at the moment the EXTJS.
EXTJS.
It's a big JavaScript data library for single-page applications with lots of tables. It's a very business data-intensive type application.
So
but I want to inject more Scala-y things into it, perhaps. But I'm stuck with that one. I'm not going to rewrite.
Well, actually, usually people use such facets, and there is a tool that converts TypeScript. So, in fact, for most of popular libraries, you can get interfaces done by Microsoft and others in a TypeScript. TypeScript is just a type JavaScript created by Microsoft and some other corporation. So usually what people do, they simply look at which TypeScript interfaces are available, and there is a parser that creates ScalaJS interfaces from TypeScript interfaces, because they did a lot of work that can be simply used by ScalaJS community. And then you manually fix some errors and you get this facet of the library. So if you stick to your XTJS, like for instance, some people use Angular, they created Angular facet and they use Angular in ScalaJS Same for D3, same for many other libraries. So you can create this interface and use it from ScalaJS easily. Yeah, well, actually, the community is quite active, so you can just go to ScalaJS Google group and one moment. Hello. Hi.
Anyway, thank you very much.
Hello. I don't hear you. Oh, barely. I don't hear you.
Bon, à peine. On enchaîne là, on en fait une autre. Très bonne journée.
En fait j'ai remarqué que vous êtes le même groupe, le même groupe que c'est autant que Scala?
Non, c'est la seule. C'est déjà bien suffisant. Ouais, voilà.